Greetings. This video we're focusing on simplifying rational expressions, which for us is target number 37B. Key thing for this presentation is that we should be trying to do as much as we can with no calculator, and we're going to be focusing on our lovely fractions throughout that process. As we talk about simplifying rational expressions, these three things are not allowed ever in the denominator. We never want an I down there, we never want a square root, and we never want a decimal. These things are typically moved out. Negative signs we don't like to have in the denominator, and fractions we don't like to have in the denominator either, and so those are the things we'll be focusing on today. So, rationalizing the following: if you have one term in that denominator, then you need to multiply by the thing that gets rid of that bad part. That bad part here for this first example is a square root. So we want to get rid of that by multiplying, just like we did in the example. You're going to multiply by that square root of 3 on top and bottom, of course, because you want to multiply by a big total of 1. So as you simplify, that's going to become 3 square root of 3 all over 3, because square root of 3 times square root of 3 cancels out that square root. And then now those 3's cancel, so this all simplifies nicely to just the square root of 3. Whereas for the second one, you've got 3 and a square root of 5 in that denominator. So I don't really worry about the 3. That's not the bad part. It's the square root of 5 that's bad. So that's what you're going to multiply by, just the square root of 5 on bottom. But of course you have to multiply the square root of 5 on top. So as you simplify, this becomes 2 square root of 5 all over, I still have a 3, and then a 3 times 5, because those square roots will cancel each other out. So you can then finish this by saying 2 square root of 5 all over 15. Nothing reduces there, so then you are done. Now for the one on the bottom left, you have an I. The I is what's bad on the bottom, not the 5, just the I. And so that's what we're going to multiply by. We're going to multiply by an I in the bottom. But of course, if you multiply an I on the bottom, multiply by an I on top. So this becomes 2I over I squared. Now you can do a little bit better than that, because I squared is -1, and so you're doing 2I divided by -1, which is just a -2I. And then you're done there. Same idea for 6 over 2I. It's just the I in the bottom that's bad. I don't care about the 2. It's I don't want. So I'm going to multiply by an I on bottom here, which means I got to multiply by an I on bottom on top there. Not squared, just the I. There we go. So this turns into 6I over 2I squared. And I squared is a -1. 6 over 2 reduces, so this all turns into a -3I on top, because 6 divided by 2 is 3. I squared is -1. And now for that last example, you've got 2 plus 4I, all divided by 6I rather. Again, it's not the 6 that's bad, it's the I that we don't like. So we're going to multiply by an I on bottom and on top. Now this one's a little bit different because you have 2 terms to distribute that I to. So this is going to take a little bit more simplification. So you've got 2I plus 4I squared all over 6I squared. Okay, well now there's some more simplification that can be done, because 4I squared is a -4. So this is really -4 plus 2I all over -6, which that is going to require one more step of simplification, because you can reduce all of that with the negative and the 2 that goes into all these. So this is going to become a 2 minus I all over 3 as our reduction occurs and all that. Now this last example can be taken one step even further, because notice that this is a complex number, and we like our complex numbers to be written as A plus BI form. And so you just need to divide each of these parts. So if you want to write it that way, it'd be 2/3 minus 1/3 I. Now it's in your A plus BI form, your complex number form, where you have the real part and then you have the imaginary part. Now these examples are all two-term denominators. And if you have a two-term denominator, do a little bit more than just multiply that one thing because of that plus or the minus that's in those examples in the denominator. So if you have two terms down there, you need to multiply by the conjugate, right? So that's right, you have to multiply by the conjugate, which will really help you simplify stuff. So if you have 6 plus I, you're going to multiply by 6 minus I on bottom and on top. And so as you distribute all that, that becomes 30 minus 5I all over, and then you need to multiply this 6 plus I, 6 minus I conjugate, which would become 36 minus I squared, which would equal 30 minus 5I all over 37, because I squared is a negative 1, so you have to add 1 to 36. And then for the second example, you're going to multiply by negative 4 plus 2I on bottom and on top. And as you multiply that, that's going to require a little bit more work. You might have to do the generic rectangle. So that generic rectangle for the product that's on the top, you can see that down here. Make sure you're multiplying all those parts correctly. And when you multiply all that stuff on the top with the generic rectangle, you get this. And then if you multiply your conjugates on the bottom, you get that 16 minus 4I squared. There's more simplification to do here. And because 2I squared is negative 2, and 4I squared itself is negative 4, and then make sure you're subtracting those things, this becomes a negative 30 plus 10I all over 20, and that, of course, can reduce with all those by a factor of 10. So as you pull out that factor of 10, you're going to get that negative 3 plus I all over 2. So that's a long process, but make sure you do that generic rectangle correctly for the top part, because these are not conjugates on the numerator, but they are conjugates on the bottom. So you will get something that simplifies with those I squareds, and then just see if you can simplify or reduce any of those fractions for your final answer. And then for the last example, you have 5 plus the square root of 2. So it's not an I problem, but you still will use the conjugate multiplied by 5 minus the square root of 2 to get rid of that square root in that bottom, which we don't want to have. And you have to do that on top as well. So you have 5 minus square root of 2 there. And then as you distribute, you're going to end up with your 15 minus 3 square root of 2 all over 5 times 5, which is 25 minus 2. So then your final answer, as you simplify all this, becomes 15 minus 3 square root of 2 all over 23. Now again, you would check to make sure if this can reduce, which it can't in this example, but that's what you would want to do. Now once we start adding x's into our fractions in our multiplication or our simplification, the key is whether or not you can factor. So you always need to factor as far as possible. So for this first example on top, you want to factor both of those on top and bottom. So if you factor those correctly, it's x minus 3 times x plus 2 all over x minus 3 times x minus 4. And then you want to reduce anything that can be reduced, and x minus 3 divided by x minus 3, so your answer is x plus 2 all over x minus 4. Note, there's no more reduction that can occur here because this is a sum and that's a difference, so you can't cancel out parts. Every once in a while I get students who want to do that. For the second example, same thing. You want to factor as far as possible. Multiplying fractions is no problem. Multiply the top, multiply the bottom, so you got to factor all of that. So if factored correctly, you should end up with this, x minus 4 times x plus 2 all over x minus 5, x minus 4. Pull out an x, so x times x minus 5 and x minus 2 and x plus 2. Then you cancel everything on top and bottom, so x minus 4 and x minus 4, x minus 5 and x minus 5, x plus 2 divided by x plus 2. So this all simplifies pretty far down to x over x minus 2, and you are finished with that example. For your final example, now you are dividing. So again, we don't want to divide fractions. You want to multiply by the reciprocal as you do your factoring. So I'll do both of those steps in one here. So you can see that I have factored the 4 out, so you get 4 times x plus 3, nothing to do in the denominator, but I'm changing the division to multiplication as I flip this fraction. So x on top divided by x plus 3 times x minus 3. So those x plus 3's will cancel out, and also this x with one of those will cancel. So you're left with 4 on top, and that's it. All divided by 3 times x minus 3. So factoring and canceling anything in the numerator and denominator is a key part to simplifying anything that has x's in it.